Hi everyone, and welcome back to educator.com. In this mini lesson, we're going to talk about magnetism, and what we're going to do is go through the first page of the A+ Physics worksheet on magnetism, which you can find through the link down below the video. So with that, let's dive into question number 1. In order to produce a magnetic field, an electric charge must be, well, the charge must be moving in order to create a magnetic field. The charge by itself without moving would create just an electric field. It has to move to get a magnetic field. Number 2, the diagram below shows a bar magnet. What is the direction of a compass needle placed at point A? Well, the magnetic field goes from north to south outside the magnet, so the magnetic field would look like this. And remember that a compass lines up with the net magnetic field. So if we put a compass at A, it's going to go in the same direction as the net magnetic field, or to the right. The diagram below shows the magnetic field near point P. If a compass is placed at point P in the same plane as the magnetic field, which arrow represents the direction of the north end of the compass needle will point? Well, that's going to again line up with the net magnetic field, which is going to be up and to the right, so our correct answer must be number 2. Number 4, which type of field is present near a moving electric charge? Well, moving charges create magnetic fields, and because it's a charge, it already has an electric field. So we're looking for an answer with both an electric field and a magnetic field, number 3. Number 5. A student is given 2 pieces of iron and told to determine if one or both of the pieces are magnets. First, the student touches an end of one piece to one end of the other, and the 2 pieces of iron attract. Right away, we know at least one is a magnet. Otherwise, they wouldn't attract. Now, the other one could be just a piece of metal that's attractable by the magnet, or it could be a magnet as well. Next, the student reverses the ends of the pieces and again touches the ends together. The 2 pieces attract again. Well, if they were both magnets and they attracted one way, when you flip it around, they should repel. So they both can't be magnets. What this tells me is one is a magnet and one is a magnetic attractable, we'll call it. What does the student definitely know about the initial magnetic properties of the 2 pieces of iron? And we figured that out going through the problem. One must be a magnet, the other must be a magnetic attractable. Number 6. The diagram below represents a wire conductor, RS, positioned perpendicular to a uniform magnetic field directed into the page. Describe the direction in which the wire could be moved to produce the maximum potential difference across its ends, R and S. Well, to do that, the easiest answer to my mind would be to have it moving left or right, crossing through those magnetic field lines to get the greatest induced current. And the last one here, number 7. The diagram below shows the lines of magnetic force between 2 north magnetic poles. At which point is the magnetic field strength greatest? Well, remember, magnetic field lines show the direction of the magnetic field, and where they're most dense, you have the strongest magnetic field, and where they're least dense, you have the weakest magnetic field. So where are the lines most dense? Right there around B. Correct answer, number 2. All right, hopefully these went very well. If they did, you're ready to move on, go to AP level questions. If they didn't go so well, probably time to go back and review the lesson on magnetism. Thanks so much for your time, everyone, and make it a great day.